Hello, this is part C of the Chapter 7 lesson. And in this part we're going to introduce our third type of hypothesis test that we call the goodness of fit test. So to introduce this type of test, let's look at this example. This is example 7.6 from the textbook. Last year at a university, a study of the exercise habits of students found that 60% do not exercise regularly, 25% exercise sporadically, and 15% exercise regularly. So what happened here is some researchers went out and maybe they interviewed every single student on this campus and found these different percentages of exercise habits. And so this set of percentages is generically called the distribution of the exercise habits. We've seen that term distribution before when we talked about the binomial distribution and the normal distribution. Same word, a little different context, but the same basic meaning. Okay. Now, in the next year, the researchers went out. They didn't survey every single student on campus. They surveyed only 470 students on campus and asked each one, how much do you exercise? And out of those 470 students, 255 exercise regularly. Do not exercise regularly, 125 exercise sporadically, and only 90 of them exercise regularly. So the question that the researchers want to ask is, does it appear that the distribution of exercise habits has significantly changed? Meaning, have the proportions of these different categories of exercise habits, have those changed very much? So the claim, or the research hypothesis that we're going to be testing, is that the distribution has changed. Now, just based off the given data, it's hard to tell if the distribution has changed or not. But it seems kind of reasonable to believe that it has changed from one year to the next. Now, just how much has it changed or how has it changed, we're not sure yet. But we're just going to claim that the distribution has changed. So let's make an observation here. We have two populations. The first population is all students from last year, and the second population is all current students. And we are really comparing these two populations. We're comparing the distribution of the students from last year to the distribution of the students from this year. So the first step in any hypothesis test is to define the parameters. In this type of hypothesis test, we're going to have three parameters, one for each of our different categories of exercise habits. And so P1 will define to be the proportion of all current students who do not exercise regularly. P2 is the proportion of all current students who exercise sporadically. And then P3 is going to be the proportion of all current students who exercise regularly. Notice that in all these parameters we use the word all. That's again to stress the fact that we are making a claim about the large population of all students, not just the 470 in our sample. Now the next step is to state our hypotheses. Remember, we have two, the null and alternative hypotheses. The null hypothesis is basically the statement that there is no change or no difference between our two populations. So if there were no change from one year to the next, then P1, the proportion of current students who do not exercise regularly, would equal the proportion who did not exercise regularly last year. Likewise, P2 would equal the proportion who exercised sporadically last year, and then P3 would equal the proportion who do not exercise at all from last year. And so our null hypothesis is going to consist of three statements of equality. It's going to be the statement that P1 equals 0.6, that's the proportion from last year. P2 equals 0.25, again that's the proportion from last year. And then P3 is going to equal 0.15, that's the proportion from last year again. Now the alternative hypothesis is going to be the same as our claim or the research hypothesis, and that claim is that the distribution has changed, or in more formal terms, the alternative hypothesis is that at least one proportion has changed. Another way of stating the alternative hypothesis is that the null hypothesis is a false statement. But this type of test, the hypotheses are a little bit different than some of our previous types of tests. The null hypothesis is not just one statement of equality, it's three different statements of equality. Now, an equivalent way to describe our hypotheses are that the null hypothesis is the statement that the distribution has not changed, and the alternative is the statement that the distribution has changed. Now we're ready to do the hypothesis test and the number crunching. The test that we're doing here is called the chi-squared goodness of fit test. And if we go to the workbook chapter 7 and the worksheet goodness of fit, we're going to see something that looks like this. Like always, the yellow cells are things that we change, and the green cells are what's automatically calculated. We have different categories, and in this case our categories are, we have just three of them. The first one is the proportion that do not exercise regularly, and then sporadically, and then who do exercise regularly. In this worksheet we can enter up to 10 different categories, but we could really do more than that if we really wanted to. In the first column we're going to enter our given proportions, and these are the numbers that appear in our null hypothesis. The given proportion or the claimed proportion of the first category is 0.6, the second 0.25, and the third is 0.15. In the second column we enter our observed frequencies from our data. So in our data we had 255 who do not exercise regularly, 125 that are sporadic, and then 90 that are regular. And notice that those add up to 470. Also notice that the sum of our given proportions adds up to 1, or 100%. Next, the workbook calculates these so-called expected frequencies. And to get this expected frequency of 282, all it did was it took this total here of 470 times this given proportion of 0.6. To get this number 117, it took the 470 times 0.25, and likewise for the 70. And so these are the frequencies that we would expect to get if the distribution really has not changed. And so if we compare these observed to the expected numbers, notice that there's a difference. This one here is quite a bit lower, this one's quite a bit higher, this one's quite a bit higher. So there appears to be a difference here. That's an indication that the distribution has changed. Next we calculate the so-called contribution, and this is calculated by taking each observed frequency minus the expected, square it, and then divide it by the expected. This contribution measures informally the difference between these two numbers here. So we get a contribution from each category, and then we add that up to get 8.46 in this case, and that's our test statistic, 8.46. And this test statistic comes from a type of distribution called the chi-squared distribution. That's explained a little bit in the book, but we won't go into that here. And then from that we get a p-value. Now in this type of test we don't have a left-tailed or right-tailed or two-tailed test. These are all as right-tailed tests, but that's not terribly important for our purposes. Here we get this p-value of 0.0146. Now, we're going to interpret that p-value in the same way as every other p-value. We're going to compare that to alpha, our significance level, which is we'll always take to be 0.05. In this case, our p-value is less than 0.05, and so our conclusion would be to reject the null hypothesis in favor of the alternative. And so this means that our data support the claim, or stated another way, that the distribution of the exercise habits appears to have significantly changed from last year to this year. So it looks like things really have changed. Now let's talk briefly about this chi-squared goodness of fit test in general. The purpose of a chi-squared goodness of fit test is to compare the distribution of a population to some given distribution. In this case, our given distribution was the distribution of last year, and our population is current students, and we're interested in the distribution of that population as compared to the distribution from last year. Okay. The parameters are the proportions of the different categories. We could have 2 categories, or 3 categories, or 5 categories, or 10 categories. We're going to have one parameter for each category. Okay. The hypotheses, in general, the null hypothesis is the statement that the proportions are as given, and the alternative is that the proportions are not as given. Okay. And the requirements for this type of test is that number 1, as always, the data have been randomly chosen. And then number 2, each expected frequency is at least 5. Now, we don't know if this requirement is met until we actually do the calculations and run the test. Verifying that this is met is very easy. All we got to do is look at that column of expected frequencies. If they're all at least 5, then we're in good shape. So let's do another example to illustrate this goodness of fit test. In 2002, the weights of Americans were distributed as follows. 2% were underweight, 39% were normal, 36% were overweight, and 23% were obese. And so a question a researcher might ask is the current distribution of weights different than the distribution in 2002? So our claim, or the research hypothesis, is that the distribution has changed. Now again, just how has it changed, we don't know. We're not making a claim about that. We're just claiming that the distribution has changed. So we've got 4 different categories of weight, so we're going to have 4 different parameters. P1 is the current proportion of Americans who are underweight. P2, the current proportion of all Americans who are normal weight. P3 deals with overweight, and then P4 would be obese. So 4 different parameters. The hypotheses, the null hypothesis is going to be the statement that the proportions are as given, and so in this case the given proportions are the percentages from last year, or from 2002 I should say. So the null is going to be the statement that P1 equals 0.02, P2 equals 0.39, so on and so forth, and the alternative is that at least one proportion is not as given. Or equivalently, again, we could describe this as saying that the null hypothesis is that the distribution has not changed, and the alternative is that the distribution has changed. So to test our claim, we got to go out and get some sample data. This data is given in Table 7.9 from page 137 of the textbook. And so the researchers went out and they surveyed 3,326 people, found 20 of them that were underweight, 932 that were normal weight, 1,374 that were overweight, and 1,000 that were obese. And so to use this data to test our claim, we'll use our worksheet goodness of fit. We enter our given proportions here, our observed frequencies here. Excel crunches the numbers. Here's our test statistic, and here's our p-value. Interpret that p-value in the same way as every other p-value. That p-value is much less than 0.05, and so we would reject the null hypothesis in favor of the alternative. So what that means is that the distribution of the weights of Americans appears to have significantly changed from 2002 to the present. So it appears that things have changed. Now the next question we might ask is, well, which categories have changed the most? Well, we can kind of informally answer that by looking at this last column, a contribution from our spreadsheet. The contribution here kind of informally measures just how much difference is there between the observed and the expected. And so the bigger this number is, the bigger the difference there is, or the bigger the change from the 2000 distribution to the current distribution. And so we see here is that the largest contribution came from the second category, which was normal weight. We see that we observed quite a bit fewer than what we expected. The next biggest number over here is the obese, and notice that we observed 1,000, but we expected only 764. So that appears to have changed the most. And so kind of a real informal answer is that the category of normal weight has decreased the most, and obese has increased the most, Our other two categories have changed about the same.